Okay, so we're going to start factoring, and we're going to talk about 3 different ways to factor today. And then on Monday, we're going to talk about more. Lots of different ways to factor. The first type of method that we're going to use is GCF. So the directions are to factor using GCF. (5k³ minus 3k squared plus 4k). Now here's a common mistake that kids make on this problem. Guys, everything we've done until now, the directions were simplified, correct? This problem is simplified. So when you come into higher maths and it tells you to whatever, do a math problem, and you end up with the answer, this is fine. The only reason you need to go farther is if the directions say factor. I can't combine like terms, right? I can't do anything with this. It's a cubed, a squared, and a k. You're done. But the directions aren't simplified. Okay? The directions are to factor. Very different, and you need to know the difference between the two. Okay? If a problem just said, hey, solve this, then you're done. If the problem says factor, then you're not. Okay? So what GCF can I take out of here? The directions are to factor. What do they all have in common? Okay. So then all you need to do then is take the k out, because I've got a k cubed, a k squared, and a k, so that's the most I can take out. Leaving me with 5k squared minus 3k plus 4, right? That is factoring with a GCF. Number 2. A lot of times, Kill Point and Terrell, they always fuss because kids will get this answer and then they'll try to keep going. No, you're done. You're finished. The only reason we're keeping going this unit is because the directions say factor. Okay? The next one, 16x cubed minus 32x squared y plus 8xy squared. And again, the directions say to factor. What do they have in common that you can factor out? Look at the numbers, 16, 32, and 8. 8. And then an x cubed, an x squared, and an x. Can you take a y out? No, because this one's missing. So then you're going to take out an 8x, and you look at each one. This would give me 2x squared minus 4xy. And then the last one, everything cancels with the y's, so plus y squared. Number 3. 12x squared y cubed w minus 15x y to the 4th w plus 6x y cubed w. A 12, a 15, and a 6, what can you take out? A 3. So what else? A 3, an x, a y cubed, and a w. Leaving you with a 4x, a 5y, and a, what was left in the last one? Everything cancels but 2. This problem. You can't, if I asked you to simplify it, you would be done, right? You can't combine any like terms. If I asked you to factor it, you're telling me it can't be factored. So what's the answer? If it were to simplify, that's the answer. If that were the directions. But if the directions is a factor, and it can't be factored, what's the answer? It doesn't change anything, though. But you can. You may know what it's called when you can't factor something. That's true. It's with the Jolly Rancher. What's it called when you can't factor something? Apply it to something simpler. Think about just plain numbers.
Prime.
Yes. Oh, good job. It's prime. Remember, numbers that can't be factored are called what? Prime. These are just bigger things that can't be factored. The concept's the same though, right? It's prime. Good job. Right, now. Right, the next one. Differences of two squares. Differences of two squares. So we've done GCF. Now we're moving on to a different concept, a different way to factor. We're going to talk about lots of different ways to factor something. The problem that you're going to struggle with is when you throw all the different ways in is knowing which way to factor it. Okay? The most important thing about this is they have to be a difference and they have to be two squares. Differences of two squares. In order for it to work. Okay? So, if we have a difference of perfect squares, let me first talk about what I have written on the board right here. Okay, and since I'm videoing today, I'll write it on a sheet of paper here. I've got x plus 3, and then we have an x plus 3 and an x minus 3. If I foiled this first one, I'm going to get x squared plus 3x plus 3x plus 9. These join together, giving me x squared plus 6x plus 9. Accurate? Okay. Versus, what's different about the second set of binomials? This is plus and plus, and this is a plus and a minus. So when I foil this one, I'm going to get something a tiny bit different. What's going to happen every time with those two middle terms? What do? They go away. Okay? Which is the reason this works, because look what happens. I get x squared minus 9. Okay? What it means is that if you had an x squared plus 9, and you try to think it means x plus 3 times x plus 3, it doesn't, because x plus 3 times x plus 3 has a middle term answer, because they did not cancel. Do you see? The only time that this little trick works is if it's a binomial, in other words, two terms. The first one has to be a perfect square. The last one has to be a perfect square. But most importantly, what has to be in the middle? A minus. Okay? Because if you tried to do this, it doesn't work. So then let me show you then the first problem. If I give you x squared minus 64. Kids look at this and they're like, I don't know what to do. So your first step is there a GCF? Well, no. The second step is, does it have two terms? Yes, two terms. A, is there a negative in the middle? Yes. B, are they perfect squares? Yes. So you can factor. And the way that you're going to say that is, what's the square root of x squared? X. What's the square root of 64? 8. So then the answer then is just x plus 8 and x minus 8. Because when I FOIL this out, what's going to happen to the middle term? It's going to go away, and you're going to get x and x makes x squared. 8 and 8 make 64. Okay? That's the reason that it works. The next one, number 2. Four x squared minus 49y squared. Again, two terms. What's in the middle? A minus. Good. That's the only way it works. Minus in the middle, two terms. Are they perfect squares?
Yes.
Okay, so this would be a 2x, and this is a 7y, right? You're just essentially taking the square root of it. So therefore, your trick would be 2x plus 7y and 2x minus 7y. It doesn't matter if you put the minus first, as long as you have one plus term and one minus term. Because when you FOIL it out, right, it's going to look like this one. The middle terms go away, and that's why it works. number 3. X to the 4th minus 81. Two terms, check. Minus in the middle, check. Are they perfect squares? Are they? Yeah. X to the 4th is the same as x squared times x squared. So the square root of x to the 4th is x squared. The square root of 81 is 9. So your answer is x squared plus 9 and x squared minus 9. Can you go farther with that?
Yes.
Yeah, be careful. Which one can you go farther with? The first one or the second? This. This can be factored again, guys. Can't it? Two terms, minus in the middle, and they're both perfect squares. So this is an x and this is a 3. So your final answer, you just bring this part down. X squared plus 9, and then you factor this one again. X plus 3 and x minus 3. Try number 4. Two terms, check. Minus in the middle, check. Are they both perfect squares? Yes or no?
Yeah.
Yep. This would be 3x. This is yz. So you end up with 3x plus yz and 3x minus yz. X to the 4th, y to the 4th. Two terms, check. Minus in the middle, check. Are they perfect squares? Yeah. Yes. They all three have to be true in order to use difference of perfect squares. This would be 4x squared and 9y squared. Giving me 4x squared plus 9y squared and 4x squared minus 9y squared. It's all done. Yes or no? No. No. This can be factored one more time. Giving you 4x squared plus 9y squared. That one stays the same. This one becomes 2x minus 3y plus 3y. The order doesn't matter. What about this one? Minus in the middle? Yes. Two terms? Yes. Are they perfect squares? No. Okay. The directions are to factor them. So factoring with different squares doesn't work. What's another method we know to factor? GCF. Is there a GCF? If there wasn't, the answer would be what? Right. But is there a GCF? Yeah, it's kind of minor. There's not much you can do to it, but you can take the GCF out first, giving you 4x squared minus 9. Now look at it. Can I keep going?
Yeah.
Yeah, again, minus in the middle, two terms. They're perfect squares. So you can factor this again, giving you 2 times 2x plus 3 and 2x minus 3. This can be factored one more time. Two terms. Yes. Minus in the middle. Is there a minus in the middle? No. Are they perfect squares? Yes. So does that make this 4x plus 7 and 4x plus 7? No. If you do 4x plus 7, just put my desk, thank you. If you do 4x plus 7 and 4x plus 7, remember, you get this. You get a middle term. Is there a middle term there? Mm-mm. Cube factor. And so let's go to another step. Is there a GCF? Nope, there's not. So what do we call this one?
Prime.
We're going to switch gears. Sum or difference of two cubes. Sum or difference of two cubes. With what we learned so far, we learned GCF. Then we learned difference of two squares. This is different. This is allowed to have a sum or a difference. When you look at something and it has two terms, okay, if they are both perfect cubes, it doesn't matter what sign's in the middle, all right? So, knowing that, let's talk about really quickly your perfect cubes in case it's been a while. 1 cubed is 1, 2 cubed is 8, right? What's 3 cubed? 4 cubed?
64.
And 5 cubed? Good, alright. So you know your cubes. So we're going to be looking for two terms, plus or minus in the middle, and perfect cubes. Let's give one a shot. Oh, well, hang on. I got ahead of myself. Let me show you the algorithm. If they are adding, if your two cubes are adding, then when you factor, you get a plus binomial, cube root of both, right? A cubed A. And then you multiply it by a trinomial. You square the first term, you multiply them together, change the sign, and you square the second term. Isn't that weird? It's huge. When you factor a perfect cube, you end up with a binomial and a trinomial. Now, what happens if we have a cubed minus b cubed? You can still factor it, except your binomial has a minus in the middle. Notice plus, plus, minus, minus. And your trinomial, again, whatever this was, you square it, multiply them together, change the sign, and you square the last term. Okay, that's kind of messy and hard to remember. But no PSAT test, no SAT test, right? Not even my test is going to give you the formula. So you have to memorize it. So I'm going to show you a really cool shortcut, like to help you remember. The directions, of course, are still factor, not simplified, very different. And the first problem I'd like for you to try is x cubed minus 8. I'm going to ask you to factor that. And it does factor. Okay, let's check off our little list here for a second. Two terms, check. Okay, minus in the middle, yes. Okay, but are they perfect squares? No, they're perfect what? Cubes. So it doesn't matter what the middle term is. They're perfect cubes, right? So if we write down what they are, the perfect cubes below it then would be the cube root of x cubed is x, and the cube root of 8 is 2. Right, so taking the square root, the perfect cubes, so we're going to take the cube root. Right, and because it's a minus, our little trick is going to be a minus b, and then the word sofas, like a couch. Sofas. And let me tell you what the sofas stand for. You ready? Okay, so the first thing you do is the a minus b. Well, what do you think the a and b, what do you think they're going to be? Same as before, right? The x and the 2. It's a minus, you'll notice, because this is a minus. And if you look back up here, plus, plus, minus, minus. So our first step then is just, I'm going to put it down here, x minus 2. Now I'm going to tell you what they all stand for. The s stands for square the first term. The s stands for square the first term. What is the first term, guys? X. So we're going to square it, and it becomes x squared. Now you'll see that there's an O and an A. The O and the A are what determine the signs because they're all so different all the time. So the O stands for opposite. So that is the O, opposite. What I mean by opposite is what was it? It was a minus, so now we're going to be a plus. The hardest one is this one, the word factors. Kids don't quite understand where that comes from. Well, what are the two factors we found? The x and the 2, or you can look at them here, the x and the 2. Well, and the other confusing thing is ignore the sign. Your sign comes from the O. The O tells me the sign. The F tells me what to put there, the factors. So the factors are x and 2, so we're going to write 2x. 2 times x is 2x. That's where the factors come from. The factors come from the cube roots. Now then A. A stands for add. It's the other sign. So you're going to put your add symbol here. And the last S is kind of like the first S. It stands for the square of the second term. Square the first term, you square the second term. Square of the second term. Square of the second term. So what's 2 squared? 4. 4. Okay. Now, look what happens. You factored this binomial into a binomial and a trinomial. That's how it's factored. If I FOIL this all out and I combine like terms, I'm going to get x cubed minus 8. That's what it is. Okay? Now, your little trick, your a minus b sofas, the a minus b is here. If this is a plus, you would use a plus b. Let me show you another one. Does everybody, actually before I do that, let me walk you through one more time. The S stands for squaring the first term. So x squared is x squared. The O stands for the opposite. So if I was a minus, I'm now a plus. The F stands for factors. The factors were x and 2. So I used 2x. And then the A is always going to be an add. And the square of the last term, add a 2 and it turned to 2 squared, which is 4. That's what it comes from. Sofas. Let's try one on your own. How about 8a cubed plus 27? We don't have a lot of time. We're going to work right to the bell. Just so that make sure you understand them. Okay, ready? This is a 2 binomial. This is a plus in the middle. Yes, I'm allowed, right? Are they both cubes? Yes, this would be 2a, and this would be what? 3. You guys take notes to the bonus, right? Unless you understand it. Now then, to find it, it's a plus, so I'm going to say a plus b, right? So in this case, we're going to use 2a plus 3. And then our SOFA's little trick. SOFA's means s, square the first term, which is 4a squared. Oh, thank you. Thank you. Square the first term. O stands for opposite. So if I'm plus, I now turn to minus. F stands for the factors. So 2a times 3 is 6a. Do not worry about the sign. The sign was decided by O. So 6a. A stands for add, and the last s is the square of the last term, which is 9. Try another one. 64y cubed minus 1. 64y cubed minus 1. It's a binomial. Minus in the middle and the both perfect cubes. What's the cube root of 64? 4y. What's the cube root of 1? 1. So we're going to say, okay, 4y, what's our sign? Minus 1. Then sofa. Sofas, ready? 16y squared. Opposite means a plus. Okay, the factors is the weird one. What are the factors? 4y and 1 make 4y. Then add, and the last s is square. What's 1 squared? 1.